Hi everyone, and welcome to today's Chemistry Daily Booster. This is number 9 in our series and does have that lovely purple box at the bottom, which means this is listed on that advanced information topic list. This time only for those of you doing higher tier, but do remember that doesn't mean it's completely irrelevant for those of you doing foundation, because of that delightful little line telling us that they're going to assess everything anyway. What we're doing today then is we're going to have a look at the start of basically formulas, how we use them in chemistry, how we construct them, and a couple of bits about the periodic table. So to start off with, we can have a look at some of the basics here. Most basic thing I hope we know from Key Stage 3 is when you look at the periodic table, remember you get one in every chemistry paper. That's the data sheet. If you turn it over, you'll find the entire periodic table on there. Please turn it over in your exam. Then what you'll find is you have a version of the periodic table. We need to remember that to the left of this little black line that I've drawn down there, those are all the metals. So all of the left hand side are metals, and then anything to the right of that little black zigzag line are the non-metals. So metals to the left, non-metals to the right. When we want to write the formula for a metal, what we're actually going to use is the empirical formula. Link back to some of our earlier work there. Empirical formula is the simplest ratio of all of the atoms present within a particular chemical formula. If we're talking about a piece of zinc, for example, it only contains zinc atoms, therefore we just write it as Zn. When we are writing chemical formulas, please can we be careful with how we do this. The first letter should always be a capital. The second letter should always be lowercase, if it has one, of course. Do go careful on that and make sure that it certainly looks like capitals and lowercase letters, because sometimes it can be a little bit iffy and that can be a notation error. When we look at the actual structure of the periodic table, hopefully remember the vertical columns are the groups, and right at the far right hand side, this little column here, that is group 0. Now, group 0 are the noble gases. We will look at those at a later stage in chemistry, and they all exist as individual atoms. And the reason for that is that they've got a full outer shell, so they don't bond with anything else. So each of those would just occur as the symbol alone. No numbers, because they're a single atom. They are monatomic, one atom. If we go one column to the left, there we go, number 17 labelled on here, or group 7 as we more commonly know them, the halogens, then these are always what we refer to as diatomic. So di meaning 2, atomic, atoms. So whenever we see anything in group 7, you must have that little 2 in the bottom right corner of the formula. If you don't do that, anything they ask you to balance with one of these group 7 elements present is going to be wrong. It's the most common way that people throw away the 2 marks on a balanced symbol equation, is because it's got a halogen in there and we just write Cl. Always Cl2. So F2, Cl2, Br2, I2, At2, always the little 2 in the bottom right, because they go around as a pair. Those 2 atoms are covalently bonded together. Do not forget. One of the most common types of formula that you are going to see used in chemistry is the molecular formula. And this is incredibly useful to us because the molecular formula tells us 2 key things. Firstly, what elements are present, and secondly, how many of each element is present. So if we have a little look at, let's just pick a random one. So let's do NaOH, so sodium hydroxide, okay? In this case, what we can do to work out how many different elements are present, then I always suggest look at your capital letters. We've got 1, 2, 3. So there are 3 different elements. Na is sodium, O is oxygen, H is hydrogen. We know the A is associated with the N because it's lowercase, therefore it is the second letter to an element symbol. Now we've got 3 different elements and a total of 3 atoms in that case, because 1 sodium, 1 oxygen, 1 hydrogen. If we have a look at something different, so magnesium this time, so Mg, again we're still going to have hydroxide, That's the formula for our magnesium hydroxide. Now, what we can see is we still have 3 different elements, magnesium, oxygen, hydrogen, but when we come to count them, there is 1 magnesium. This little 2 outside the brackets means that we multiply everything in the brackets by 2. So that means there are 2 oxygens and we have 2 hydrogens. We don't have 2 magnesium because it's not in the brackets. So the brackets tell us how many we've then got from the bottom right number. Do remember that little fact though. It's not just 2 hydrogens. It's 2 hydrogens, 2 oxygens, 1 magnesium. Some basic rules for us to remember, and one of my kind of good hints here for when you go into the exam is as soon as they tell you that you can turn over to start your actual papers, flip over that data sheet and put those little charges at the top of your group numbers, just as that reminder to you. So anything in group 1 will have a +1 charge, so sodium atoms become Na plus ions. Group 2 +2 charge, group 3 +3 charge. So literally whatever the group number is on the left hand side, for 1, 2 and 3, just stick a plus in front of it, that's the charge on the ion. If we go to the right hand side, groups 5, 6 and 7 follow a similar pattern, but these are negative. What we're basically doing here to work out the charge on it is how many more do we need to get to the number 8. So if we look, from 5 to 8 is 3, so it gives us a -3 charge. From 6 to 8 is 2, -2 charge. From 7 to 8 is 1, a -1 charge. Because what's actually going to be happening to form those ions, they're gaining electrons to get that full outer shell. So the full outer shell is going to be 8 in these cases, therefore 5 from 8 gives us -3, then 6 is going to be 2, 7 is 1. Don't forget the negative charge there. The other bit, the middle section, that little block of the transition metals, these typically have a +2 charge, but there are exceptions. And the way that we're going to be able to identify the charge on those transition metals is the Roman numeral in brackets. So in this case, if we've got iron with 3 in brackets in Roman numerals, that would actually be Fe3 plus ions. Okay, so whatever the Roman numeral is, that's going to be the number of positive charges. Here's some to learn then. There are 5 compound ions. Now, a compound ion is just an ion that contains more than one element. These are the common ones that you could be asked to use to construct formulas on your exam paper. So learn them. Literally, stick on the front of a flashcard. What is the formula for the ammonium ion? On the back, NH4+. If you learn these, you're going to be able to construct the formulas of the chemicals very easily. If you don't know these, you're going to hit some problems. So I'm not going to read them out to you. Obviously, find a suitable time, hit pause on the video, make sure you know each of these. So ammonium, hydroxide, nitrate, carbonate, sulfate, all 5 you need to know. As far as actually working out the formula for an ion sort of compound, if you like, then what we're going to be doing here is, if we were going to have, let's do sodium nitrate first of all, okay? Now sodium is in group 1, so that means sodium has Na plus ions. I do apologise for my terrible drawing with a mouse. And then nitrate is NO3 minus ion, okay? So if we're going to join these together, we've got to make sure there are the same number of positive as negative charges. So we have 1 positive charge on sodium, 1 negative charge on the nitrate. So in fact, 1 sodium ion is going to join with 1 nitrate in order to make sodium nitrate. If we had a different scenario, so let's go to our little common example here of magnesium in group 2, 2+ ions. We're still going to use the nitrate though, okay? We've got 2 positive charges in magnesium, but only 1 negative in the nitrate. They have to cancel out. So that means we would have 1 magnesium, but then we're going to have 2 nitrates, because obviously we need 2 negative charges. So what we do is we put our NO3, our nitrate, in brackets, And then, because we need 2 of them, put a little 2 in the bottom right. That means we've got 2 negative charges because we've got 2 nitrate ions, 2 positive charges from magnesium. That's our final formula. Just make sure those charges balance out. We do have this thing called the law of conservation of mass. Very basic. Atoms cannot be created or destroyed. This means that if we have questions that give us the mass of the reactants and one of the products, to get the mass of the other one, all you've got to do is total mass of reactants minus the mass of the product we know. Whatever's left gives us the one we're being asked for, because the mass has to be the same for the total reactants and total products. Types of equation you could be asked to do. Word equation, particularly on foundation paper. Usually that will just be a question that tells you magnesium reacts with oxygen to make magnesium oxide. Write the word equation for this. So quite simply you write magnesium plus oxygen. So wherever the and is, replace it with a plus. And then whatever it says it makes, there's your arrow, and then what it makes on the right. Just remember, word equation means use full words. Do not cut round and use symbols, because it's not a word equation if you've used a symbol. The balanced symbol equations, this is where we're going to be adding numbers in front of the formula. You can't put it anywhere else, it has to go in front of the whole formula to do this. So please just be careful on that to make sure you're not changing chemicals themselves. The only place you could put it is in front. So let me think of a quick example here. Let's do sodium and water is going to make sodium hydroxide and hydrogen. So the way I suggest you do this, divide it into the 2 sides first of all. Now once we've divided it into the 2 sides, what we actually have are sodium, hydrogen and oxygen. So we've got the same elements on each side. We have 1 sodium, 2 hydrogens, 1 oxygen there. On the right, again, we've got sodium, hydrogen and oxygen. So we've got 1 sodium, 1 oxygen and 3 hydrogens. So clearly it's not balanced because we've got 3 hydrogens on the right, 2 on the left. So what can we do? Well, if we've obviously got 3 on the right, we're going to have to add more hydrogens. So if we think about how we can do this, then we can only put numbers in these locations. So you can put a number in front of the hydrogen, number in front of your sodium hydroxide, number in front of the water, number in front of the sodium. Nowhere else. If you do anything else, you change the entire formula. It doesn't work. So what we're going to do here then is we are actually going to add our little 2 here, because that then means we're going to have 2 there. We've got 4 hydrogens and we've got 2 oxygens in that case. We're still not balanced because obviously this doesn't now add up, but if we add a 2 in front of our water, that takes that to 4, oxygen to 2, and then we need to put 2 in front of the sodium, takes that to 2 as well. Job done, all balanced. Practice balancing, it's a guarantee. Balancing equations are going to be worth 2 marks. 1 mark is for getting the formulas right, so even if you didn't balance it, if you had Na plus H2O makes NaOH plus H2, that's your first mark. Second mark is the balancing one. Final little bit that we're going to have as our recap are the state symbols. Again, these just show us the physical state of substances in a chemical reaction. So S is solid, L is liquid, G is gas, AQ, aqueous solution. Last thing for you to do today then is head on over and have a go at the quiz, check your understanding of these concepts. I would suggest practicing balancing. You will be able to find a large number of balanced equation worksheets with examples on the internet if you do a quick Google search, because that is a question that I guarantee is going to come up at least once on every paper. It can be the difference between one grade and another for you if you get them right. So really take the time to balance things. Don't forget to join us again tomorrow for our next Chemistry Daily Booster.